So now let's go through some examples of how to do a word problem going through those same steps. So let me share my screen here a little bit. And we're going to just share the screen. And we're going to start the slideshow from the current slide. And so if you have an oven and you want to figure out how much power that oven uses to calculate how much money it's going to cost you to run, but you know how many amps the oven consumes. So if you have an oven that requires 45 amps of current at a voltage of 240 volts AC, what is the power requirement for that oven? So let's go through our steps. So the first step is figure out what we know and what we're looking for. All right, so what solution is the problem asking for? What's its unit of measure? So number one, we know that we're looking for power, P, and we can assume if you're looking for power in an electrical question, it's going to ask for it in watts. And the second part of that is what do we know already? And we know we have the current I, 45 amps. And we also have a voltage V of 240 volts. So now, this is my basic information. I've got P power, I've got current, which is I, that's the symbol for current in all our electrical stuff, and V for voltage. Sometimes they use E for voltage, but we're going to stick to V. So now we're going to go strategize. What formula do I have out there that's going to connect power, current I, and V voltage? And there's only one, and that is picked out of the cheat sheet. That's P equals IV, or poison ivy is the way I remember it. P is equal to I times V. That's very simple. And then I'll have to set up the formula. P equals IV. Let's fill in the values. 45 amps is current, or I. 240 volts is V. And I solve it. My last step is solve it. And I just multiply the two. I'll probably pull out my calculator to do that. It should come out to about 10,800 watts if I used my calculator correctly. So my power is 10,800 watts. The answer is very, very simple. Simple plug and chug. But let's do a little bit more complex example, because you can't always find exactly the right formula you're looking for. Sometimes you have to calculate something first. It has to be a two-step operation before you can fill in the final formula. So let's go sample 2. Your shop jack is lifting a car. The pressure measured in the main jack cylinder is 500 psi. Now psi, you should know, stands for pounds per square inch. That's pounds divided by inches squared. And your jack cylinder has an inside diameter of 3 inches. About how much does your car weigh? Weight, it might be a tricky one from you. Weight is always the force downward created by gravity. So we always measure weight in pounds. In our English world, it will be kilograms in the UK or Europe. But here in the United States, we use pounds. And so let's do the first step. Identify what are we looking for. What do we know already? The solution is force or weight in pounds. And we know we've got pressure of P in 500 psi, pounds per square inch. And the diameter is 3 inches. So you may not know how jacks work, but we know we've got a cylinder. So let's do the drawing step, which I've urged you guys to do earlier. A cylinder, I'm just drawing a cylinder. When you have a jack, that cylinder has the force pressing down on the top of the cylinder. So the force is always pressing down. We also know that the diameter of that cylinder is 3 inches, and your pressure inside that cylinder is 500 pounds per square inch. So now, by drawing it, we can see that I need to figure out the area pressing down on that cylinder to calculate the force. Because I have, in my formula lookup book, I will need sometimes 2 or 3. So I have to do a little strategy. The first thing I found is I've got a formula which is force is equal to P times A, which is pressure times the area. And also, I need to come up with the area of that cylinder head, which I can get by using the area of a circle, which is pi r squared. Now, we still don't have 100% correct there because I need to do the 3-inch diameter. And I know that diameter is half or 2 times the radius. So I have to divide the diameter by half to get the radius. So my radius is 1.5 inches. So let's go through this again. Let's set this up. Step 1, A is equal to pi r squared. Step 2, force is equal to pressure times the area. And now I've got everything set up. So let's run through the solve. Step 1, area is equal to pi r squared, which is equal to, we're going to use 3.14 all the time when we use pi in this course. So it's 3 inches divided by 2, which is the diameter, divided by 2 is the radius, squared, which is 3.14 times 1.5 squared, which if we run it through the calculator gives us about 7 square inches. Step 2 is your force times the pressure times the area. Now I've got my area, I can plug it straight in there, and I've got my pressure from earlier, which is 500 psi, and I can plug that straight in there. And my answer, the force, the weight of that car is 3,532.5 pounds. Now the last step is check. Does 3,532 pounds sound about right for a car? Well, those of you who know a little about cars knows that's about the right ballpark. I might want to check my math. I might want to check my unit of measures. You know, for instance, pounds per square inch, if I multiply it by square inches, I should just end up with pounds. So it looks like I've done the right thing there, and that's how you solve this problem.